All right. I was looking through my notes last year, and last year I needed to like explicitly review this because my students last year had missed this in geometry because they were remote during COVID. But you guys were around for geometry, right? So you probably saw a million problems like this when you got to similarity and congruence and that kind of stuff. Yeah. So like just in case you haven't seen it, we just kind of draw some lines across the equal sign, and we multiply diagonally, and we created an equation without fraction. Are we good on that? Okay, that's the algebra skill we're going to need today. So hey, I got some great news for you folks as you're copying this down. So we've been doing some pretty cerebral stuff the past couple of days. Cerebral is like kind of high thought process type stuff. I kind of hinted at this before. This chapter has a lot of that proof stuff and simplifying, and it's just like, it's kind of can be overwhelming for some students. So we're going to take a couple breaks in the middle and do some nice cookie cutter step-by-step math, and that's what we're doing today. So if you're feeling a little overwhelmed by the proofs, put that on the back burner for right now. Today I'm going to show you law of sines. This is one of those, you do the same steps every single time, you're going to get the correct answer, okay? There are a couple tricky things that are easy to forget, some steps that are easy to forget, and there are a couple things that may seem overwhelming at first until you get in and actually start doing some problems. But I'll tell you that my students are typically very successful with this after practicing it just once or twice. Okay, so does that make you feel good? We'll break from the proof stuff for a little while. All right. First thing I got to show you is convention for naming triangles. When we draw a triangle, I'll say draw a generic triangle. What I mean by that is just draw a triangle, label it capital A, capital B, capital C. If you did not use capital letters in your triangle, please change that. Angles and vertices are capital letters. The sides are going to be lowercase letters. And the convention is that side A is across from angle A, side B is across from angle B, side C is across from angle C. Our textbook uses A, B, and C. But in other textbooks, and most of the textbooks I've used, they instead use the Greek letters alpha, beta, and gamma. I'm going to stick with what our textbook uses for right now, but if you ever end up in a class and you see the same thing with Greek letters, just know it's the same thing. They're just using the Greek versions of alpha, or A, B, and C, which is alpha, beta, and gamma. So here is the law of sines. The law of sines says that the sine of angle A divided by the length of the side across from it, that ratio is equal to the sine of angle B divided by the side that's across from it. And that, in turn, is equal to, I bet you can fill out that last one on your own. You guessed it. Sine of angle C divided by the side that comes across from it. It's kind of a weird looking equation because it's got two equal signs in it. We're never going to use this where it's got three fractions and two equal signs. We'll just pick two of these fractions with one equal sign in between it. And then how are we going to solve it? We're going to cross multiply. We're just going to solve these with cross multiplication. So there's really two things that I got to teach you. One is how to set these up, but that's pretty straightforward if you've got a picture in front of you. Two is how to solve it, but if you already know how to cross multiply, then you're already 90% of the way there. And then three, there's one tricky thing that happens when we're solving for one of these angles. So we're going to hold that for right now and focus on just solving for sides right now. Okay? You guys with me? Let's do this. Okay, can you make me a generic triangle? You don't need to worry about writing all of that information down. We're just going to put it straight onto our triangle. This is what your assignment questions are going to look like. But when I do these, I just go ahead and draw myself my triangle. I get my A's and B's and C's in the right place. And then I'll just put the numbers right next to the variables where they belong. So let's fill in the information they gave us. They gave us that angle C is 65 degrees. So let's put 65 degrees right here where angle C is. And angle B is 8. That's a very small angle, 8-degree angle. And they told us that side B is 11. And they want us to find side C. We're going to find that side there, so I'm just circling it. All right, I'm going to go ahead and set up a law of sines equation. Hang on, I need to slow down. I can tell some of us are still drawing that information. Pausing. All right, law of sines equation. Are we ready? Give me the universal sign if you need a minute. Who needs a minute? You guys with me? All right, sine of something over something equals sine of something over something. So we need to get C into one of these fractions, and 65 is the angle that's across from it. So we need to get C and 65 into one of these fractions. So let's go ahead and put it in the first one. What goes in the top with the sine? Is it the C or the 65? The angle always goes inside the sine or the cosine. So 65 goes in there. C is going to go in the bottom. And then I need some other pair of an angle and a side across from it to complete this one. And I want to make sure I know both the angle and the side. I think we're going with 8 and 11. Does that make sense to you guys? Okay. And the 8 would go with the sine, right? Because that was our angle. And 11 on the bottom because that was the side. So the angle always goes in the sine. Side goes on the bottom. Just double checking because it's really easy to get these numbers in the wrong spot and get wrong answers that way. Are we feeling okay how to write a law of sines equation? That was one of the 3 things that I told you we needed to learn. Woo! The second one was solving it. So let's cross multiply. So I'm going to go C times sine 8 equals 11 times sine 65. Anybody tempted right now to type 11 sine 65 in their calculator and change that into a decimal answer? Some people are. Thanks for being honest. We are not going to do that. Please stop hitting buttons in the calculator if that's what you're doing right now. We're not going to round in the middle of a problem. We're going to wait until we get C by itself, and then we'll put everything in the calculator all at once. Okay? So let's solve this and get this C by itself. Right now it's multiplying by sine 8. How do we get rid of multiplication by sine of 8? Divide by sine of 8. I would not normally write this on my paper. I would just write down the next step, which would be C equals 11 sine 65 over sine 8. We now have C by itself, so we're just going to punch that into the calculator all at once. Before we do, we should probably check our mode. What mode would we like to be in for angles? Like in degree mode. So double check, make sure you're in degree mode. Type that in to your calculator. Make sure your parentheses are correct. Don't forget your end parenthesis on that sine 65. And my hope is that we're all getting, let's go 1 decimal place today, about 71.6. They didn't give us units. I think in your assignment there's units, so I don't really know what to put for the units. So whatever 11 was. If 11 was in fathoms, then this would be fathoms. Anybody know what a fathom is? Fathoms is a depth measurement. I'm thinking of Little Mermaid, song from the Little Mermaid. Huh? Depth, like water depth. Would you thought I said depth? How dead you are? Yes. On a scale from 1 to fathoms, I'm pretty sure is a depth measurement. I have no idea what it means, what it is. All right, are we feeling okay so far? That's our first one. That wasn't too bad. Of course it's going to get harder, but not much. Not much. All right, number 2, this is you. I gave you some hints. And I would love for you to try this out on your own, see how you do. I will be here to support you. It's not often that I give you like one example and say, yeah, you got this, but I'm pretty sure you guys got this. This is actually harder than the one that we just did. And I'll give you a reason why. That's a good question. Have you done this before? Not in geometry, maybe in algebra 2. We don't usually teach law of sines and law of cosine in geometry, although they may be changing that this year. It's going again. Any questions? So about 20, if we're rounding to 1 decimal place, x would be 29.0. And if you happen to have time to solve for b, that came out to 36.0. I didn't hear this question today, but let me ask you guys. Once I had x, could I have just used the Pythagorean theorem to find b? No, because why not? The Pythagorean theorem only works for what kind of triangles? Right triangles. Is that a right triangle? No. Okay. All right. Okay. This next part, I don't need you to write anything down, but I need you to pay attention. This is not worth the time for you to write down. It's much more important that you pay attention to this, okay? I'm going to ask you to type some things into your calculator, and I need you to go with me. I need you to be kind of quick about it, okay? So get your calculators out. You ready to go? Could you please type the sine of 20 degrees into your calculator? And then I would like you to also type the sine of 160 degrees into your calculator. And I would just like you to tell me, what do you notice about the output of those two things? The exact same thing? Like to the 8th decimal place? Yes? Okay. Try this one. Can you please type in the sine of 40 degrees? And then also type in the sine of 140 degrees. What do you notice about those two values? They're exactly the same again? That's so strange. Could you type in the sine of 55 degrees and the sine of, who wants to guess what my other one's going to be? 125 degrees. Type those two things in your calculator and see. Are they the same? Oh my goodness. It's almost like there's a pattern going on here. So I'm glad that you guys have found the pattern. The pattern in each case is what's the relation. Hey guys, please stop. Thank you. What's the relationship between each pair of angles that I've given you? They add up to 180. They are, anybody remember from geometry, what are those called? Supplementary. Nice. Supplementary angles add up to 180. You don't need to write this down. I want you to know why this is always going to be true before we move on. And I want you thinking about the unit circle. Hey, let's not shout out answers, please. I would like everybody to think about the unit circle and tell me, let's look at this last one. What is the relationship between a 55-degree angle and a 125-degree angle? And again, please don't shout out answers. Give everybody a chance to think about this. What is the significance between those two things? Would anybody like to explain? What do you think, Miles? They would both have the same y coordinate, and that should make sense because the sine is the y coordinate. Why do they have the same y though? They're symmetrical from the origin. I like that too. Can someone give me a vocabulary term from our last chapter? They have the same reference angle. Wouldn't the reference angle for 125 be 55? So in each of these cases, the first angle is the reference angle of the second one, right? Agreed? And they're going to have the same y coordinate, and not just the same y coordinate, but they're both going to be positive always, right? Because if we're dealing with angles between 0 and 180, then we're in the positive quadrant for sine, whether we're quadrant 1 or quadrant 2. Agreed? Okay, so here I got some trouble for you here. Okay, one more. Type in the sine of 30, and it should be the sine of 150, right? Because both of them are a half. Agreed? So if I gave you an equation that said sine x equals a half, and I asked you to solve it, here's where the trouble comes in. How would a geometry student solve that equation? How would they get that x by itself? They would do an inverse sine on both sides. Could you guys go ahead and type in the inverse sine of a half into your calculator? Should come up to 30 degrees. But the problem is there are two solutions to this between 0 and 180 because the sine of 150 is also a half. So the calculator is giving us 30 degrees, but we know that 150 degrees would also work. Those aren't the only two either, right? If I wanted to find some more angles that would work for this, what could I do with 30 and 150? How could I find another angle that other than 30 and 150 that would work for this? Add 360, right? What are we talking about now? Coterminal angles. We could add 360 or subtract 360 from both of these, right? Now, if we did that, are we going to get angles that we're interested right now? Right now, we're talking about solving triangles. Are we ever going to get an angle in a triangle bigger than 360? No. Are we ever going to get an angle in a triangle that's negative? That doesn't make sense. But could we have an angle in our triangle that's bigger than 90? Yes, we're now dealing with non-right triangles, so we could have obtuse angles. So the reason I'm showing you this is we're about to run into the one complication with law of sines, and that is that sometimes when we're using an inverse to solve for an angle, we have to consider not just the angle that our calculator spits out, but the other angle that we know would also solve that equation. And so what's going to happen here in a minute, I'm going to show you, and then we'll write some step-by-steps for this too. We're gonna solve an equation, and we're going to use our calculator to find something like x equals 30. And then we're going to have to think to ourselves, there's another angle. And all we're going to do is go 180 minus whatever our calculator gave us to come up with that other angle. And we're going to ask ourselves which one of these works. Sometimes only one works, sometimes both of them work. But sometimes none of them work too. So we'll see examples of all of those. So I just want you to keep this in mind. And the big idea is that when we use an inverse, the inverse is only ever going to give us an answer smaller than 90. Only. That's just one of the rules of the inverse. We learned that the inverse has a range from negative 90 to 90. That's okay. It's only going to give us this small angle. We're going to have to do a little tiny bit of work to find the other possibility and then ask ourselves, is this possibility? Okay. This all sounds really complicated right now, I'm sure, but you'll see it and it's going to be nice and simple. Okay. Once we see a couple examples, you'll be like, okay, this isn't that big of a deal. I hope. That's my hope. So we're skipping some stuff and we're moving to this example. So as you're getting this copy down, I want you to notice that there's something different about this from the other two examples we've done so far, and that is this time the x, the thing that we're solving for, is an angle and not a side. Okay? This thing that we're talking about, this ambiguous case that we're talking about, the only time you ever have to worry about it is when you're solving for an angle. So those two problems that we just dealt with before, we would have never had to even consider this, okay? This only comes up when we're solving for an angle. And it's just at the very end that things get different. So I would like you guys to go ahead and set me up an equation. Law of sines equation. Nothing's new here except where your variable is going to end up. It's an angle this time, so it should end up in the top. So the x and the 29 is going to have to go into one of my fractions. Where'd you put the x? In the top or the bottom? X is the angle, so it needs to go inside the sign, right? Top. 29 is the side, so it goes in the bottom. And then same idea with the 34 and the 96. 34 is the side, it should be in the bottom. 96 up here in the top. You guys okay with that equation? Nothing new there. Nothing we got to worry about from what I just talked about. The next step's going to be the same as what we've been doing too. Go ahead and cross multiply for me. Some of you are going to find some more efficient ways to do this. But for right now, let's just be consistent with how we did the other one. And then we're going to work to get that x by itself. What would you do next? We could divide. Yeah, let's do the easy stuff first. We could divide that 34 away, right? Let's divide on both sides by 34. We get sine x equals 29 sine 96 all over 34. And oh my gosh, we're almost there. We just need to get that sign off of the x. Now we can't divide a sign away. What cancels a sign? Kind of, as long as we're dealing with angles between negative 90 and 90. Inverse sign. So we're going to do an inverse sign on both sides. And then that's going to leave us with, and I normally wouldn't write this down separately, but for the sake of our notes, inverse sign of, and it's a big old mess. Luckily, our calculator is going to deal with all the messiness for us. We're going to type that into the calculator, and we're going to get an answer. So far, nothing that new. Inverse sine 29 sine 96 all over 34 comes out to, if we're rounding to one decimal place, that's 58.0. Is that feeling okay so far? Put that away, come on. So here's where it comes, here's where we have to worry about that extra stuff though, because there is another angle between 0 and 180 that could potentially work, that could solve this equation. There is another angle. We have to find that other one. Our calculator is not going to give us both of them. It's only going to give us the one from 0 to 90. What do I do with this 58 to figure out what my other option is? We just do 180 minus 58. So go ahead and do that in your calculator if you need to. Maybe we can do it in our head. 122? Is that right? Okay. Why did I need to do that? Because 122 would make this equation true. We'll get to that in a minute, but the fact is that 122 degrees would make this equation that I'm pointing at true without the inverse signs on it. Okay, so it would make this equation true, but here comes the big question. Does 122 work in this situation? I got a 96 degree angle in this triangle already. Can I add a 122 degree angle into it also? It doesn't fit, it's too big. It would get us over 180 degrees and we don't even have a third angle. So in this case, we toss it out. It's extraneous. It satisfies this equation and it would satisfy our original equation, but it does not work in the situation that we're dealing with. So for this particular problem, our only value for x is 58 degrees. Okay, so up to this point, I feel like everybody's feeling pretty good. It's just this is called the ambiguous case, and it's at the very last step. The only time we have to worry about it is when you find yourself doing an inverse sign. And this only comes up with law of sines. We'll be doing something else called law of cosines later on. I think next week, actually. There is no ambiguous case for law of cosines. It's only with law of sines, and it's only when we're solving for an angle. And all we have to do is remember that when we get to this final step, there are two angles that would satisfy the equation. The other one is just the supplement of whatever our calculator gave us. We look at it. If it works, then we would have two solutions. If it doesn't work, we throw it out. And sometimes neither of them work. All right, any questions on this one before we go on to the next? All right, let's do one more example. And then I've got some step-by-step notes. I'm not sure if we'll want them or not. So we're solving for an angle again. So as soon as I see a problem like this, and I know I'm using law of sines, I'm like, oh, I'm solving for an angle. I've got to remember to do that thing where I subtract from 180 at the end. I've trained myself to do that. This is, by the way, this is one of those things that like just people forget to do it. It's like that thing that you've got to remember to do at the very end of a problem, and people just forget to do it. So start sort of training yourself on how you're going to remember to do this. You guys have been seeing me do this thing where I like circle the side and the angle and draw a line between them that are across from each other. There's a very good reason I do that. It helps me set up my law of sines equation. It's also, once we introduce law of cosines, doing this is going to help us determine whether we want to use law of sines or law of cosines to solve a problem. Does anybody see any issue right now with this particular problem? We don't have the side across from x. Bummer. What are we going to do? What if we do law of sines twice? Somebody had another suggestion? I thought I heard someone else say something different over here. What'd you guys say over here? Somebody said something. What if we found B? I don't know anything about it. I'll let you make that call. I don't know anything about it. You decide. Your future, you decide. So do we have to solve for B? I think we're going to solve for B because once we know what B is, then solving X will be pretty easy, right? Since we've already got one angle, if we find B, now we've got two angles. We could just subtract from 180 to find X. You guys comfortable that we could just solve for B first? All right, so let's solve for B. So sine B is across from 33. We got angle 43 degrees across from 30. Let's go ahead and do some cross multiplying. I'll let you guys kind of do your steps to get you to where we need to be. Show as much work as you need to. I am not going to show my steps. I'm skipping ahead. You guys show your steps. I'll show you where we're going to end up at. Like I said, some of you are going to come up with some shortcuts, and I'm fine as long as you write that original equation and you're getting the answers correct. It doesn't bother me any. So when you're about to punch your numbers into your calculator, check and see if you agree. This is what I'm going to stick into my calculator here in a moment. Is that where you guys ended up? If you didn't, let me know. I'd be happy to look over your steps, see if I can spot a mistake. Again, I'm not showing my steps here because I'm encouraging you to write your own steps down and make sure you're getting to the same spot. Ask a question. I'm here. If you're not getting to that same place, your steps should be cross multiply and then do a little division and then take an inverse. You know, I've had, I don't know if it's the weather or the calendar or what, but I've had a lot of people be really whiny about this today. I don't know. I don't know what it is. There's something in the air. Maybe it's the moon, or I don't know. Well, I'm not used to this beautiful weather. It's been a long time since we've had it. So maybe it's just that people are like looking out the window like, man, I'd rather be outside doing this. It's really hard to see calculator screens on a sunny day like this. This is usually one of those lessons where people are like, oh, it's so nice to have a break from proofs. So let's ask some questions here. Is anybody having any trouble getting to that 48.6 and 131.4? Are we feeling confident here? What do you suppose the biggest mistake someone would make up to this point is? Just forgetting to do that or part. So again, any strategies you can develop to help remind you to do that at the end. My personal favorite strategy is like recognizing at the very beginning, I'm using law of sines to solve for an angle. I'm going to need two answers. Now, here's going to be our last step, because we weren't trying to solve for b. We were originally trying to solve for x. So what's going to happen is, when we get to this point where b has two different values, we're actually going to create a multiple universe situation. We're going to draw the other triangle in the other parallel universe. One of these universes, I don't know whose it is. One of it has 48.6 as angle B, and the other one has 131.4 as its angle B. The rest of the information doesn't change. The 30 didn't change. The 43 doesn't change. But that one angle, that one change that we make is going to have like a ripple effect, and it's going to change other things in the triangle too. So x is going to end up having two different versions as well. And we need to find both of them for our final answer. So let's see if we can find this version of x and this version of x. Which this is the easy piece. We just need to take 180 and subtract off these two angles to find our two x's. So let's see here. Minus 43 minus 48.6. So I'm getting 88.4 for that one. And 5.6 for this one. All right. So ambiguous. This is called the ambiguous case for law of sines. And again, the only time it pops up is when we're solving for an angle and we're using law of sines. Okay, I got a pretty important question for you. I'm trying to save some time here. If the instructions had originally said solve the triangle, we would not be done yet. Because if the instructions are solve the triangle, then you've got to find all of the missing pieces. And we would still need to go back and find one more piece, which is side A. Except what? We don't know which one, so we got to do both of them. So if it had said solve the triangle, we would need to go back and find this version of A and this version of A. We'd have to use law of sines to do both of them. Okay, so which means at the end of the day, we'd end up using law of sines three times to do this one problem, and we would end up with two sets of missing values. So we would have x equals this, b equals, what was it, 48.6 and 131.4, and then we would also have a equals this or this. And then we would be done with that problem. And there is going to be one problem on your assignment where you are going to have to solve the triangle, and there's going to be two different versions. There's going to be a couple where you've got to solve the triangle and there's only one version because the second thing ends up too big. But there's going to be one where you got to do two versions, okay? So just look forward to that happening with anticipation and joy, okay? All right, can we do one more? This is the best news of the day. You'll love this one. Yes, yes, you'll like this one. Give it a shot. Give it a shot. I'm not gonna try and prepare you for this one because I want you all to experience the joy of this problem. No, actually this is my favorite one that we've done. I love these ones. Anybody anticipating that? Oh, I might have to do those two different angles, right? We are about to solve for an angle, and it looks like a law of sines problem. Because we've got angle and side across from each other, another angle side across from each other. Oh yeah, that's totally a law of sines problem. That is a terrible 3. How many of you have realized you don't really need to cross multiply when you're doing these ones, when you're solving for the angle? You can just multiply both sides to get rid of this 5. Saves you a whole like 2.5 seconds of your life. But many of you are going to decide, yeah, I'm just going to cross multiply every time because it works every time. Yep. Any scouts in here, or outdoors people, hunters, those kind of folks? So I always say I would rather have just one really nice, like lock blade knife rather than a Swiss Army knife with a ton of different blades on it, right? So that's my mathematical philosophy. I'd rather know one thing that works for a lot of different situations than have to have a million different tools to cover specific situations. So, yes. Hey. No, don't complain. This is good. This is good. X equals the inverse sine of 5 sine 73 over 4. We stick that into our calculator. We get a domain error. So our final answer is no such triangle. Spoiler alert, no. Undefined is reserved for some very specific types of things like dividing by zeros or so. You'll see a few of these come up and they'll typically be where you're solving for an angle and you get a domain error. If you want to know why this happens, so I'll show you numerically and like kind of geometrically why this happens. If I type the inside of this in, 5 sine 73 divided by 4, it comes out to 1.2. So this side of the equation is about 1.2. What's wrong with that? Can sine ever equal a number as big as 1.2? What's the biggest sine is ever going to be if I don't have any vertical stretch or anything? It went up to 1 and it went down to -1. It's never outside of that. So there's no way sine can ever get up to 1.2. So when we do the inverse sine on it, it's like, can't do it, sorry. It's outside of my domain for inverse sine. Now physically, any of you who are good construction folks, I want you to think about taking a 2x4, and we're going to cut it into 5 feet section. 1, 2, 3, 4, 5. That's 4. So here's my 5-foot 2x4. And here's my 4-foot 2x4. Okay, now I want you to imagine I'm going to lay out a template where there's a 73-degree angle, and I don't have a protractor in front of me, so I'm going to have to eyeball this. This would be like 90. We need to be smaller than 90. I'm going to say it's something like that. Okay. I'm going to lay this 5-foot piece out along here, and again, I'm just kind of eyeballing it. That's about to there. You guys like that measuring technique? And then this 4-foot piece needs to attach to the end of this, and it needs to connect back to this line that I laid out, because it has to be 73 degrees. That's what this picture up here is showing us, right? I'm here to tell you that that piece is too short. There's no way, if I'm going to nail it in to the end of this piece and try and get it to reach this, it's just not going to make it. It's not going to make it anywhere on that line. It just won't touch that line. It's physically impossible for us to make a triangle that has these dimensions on it. Okay, if you ask somebody to do it in a wood shop or out on a job site, most people will be able to look at it in a couple seconds and be like, nope, not going to happen. All right, so you'll see some of those pop up, and you're usually not going to know that that's the case until you've gone through the process of solving, and you'll get that domain error. All right, I had one more example that we did before, but it was just basically solve the whole triangle, and it ended up being a lot like example 4. Do you guys want to look at that one? No? Okay. And then I'm going to leave this up on the screen. So we wrote this out in my other class, and I would encourage you to read it over thoroughly before you take the time to copy this down word for word, because I don't know how great a job I did explaining this. I'm trying to sort of explain how to do when we're solving for an angle. Okay, law of sines. Did you catch my little abbreviation here for law of sines? So when you're using an inverse sine with law of sines, this is that complication at the end. You got to consider 2 angles. The one that your calculator gives you, and then 180 degrees minus whatever your calculator gives you. And sometimes that second angle is too big. In that case, you just throw it out and you don't use it. Sometimes it works. In that case, you've got multiple universe that opens up. I'll leave this up here if you think that's useful. Copy it down. You could probably find a better way to write it, to word that would work better for you. The assignment is, there's 2 parts to it. One of them is a worksheet that I did not print, but you can always run down to the office and print, or the library and print one here. We got some time left. And then there's a few proofs out of the book. I will not be here on Wednesday. We have a meeting off-site. So you guys are going to be working on some more law of sines practice and some more proof practice. I would love it if I got back on Thursday and I found a note from the sub that said that you guys were helping each other out on those proof problems. Please, please, please. If you're struggling on a proof problem from this assignment or the one that I'm going to give you Wednesday, ask the folks around you. Just ask for a hint. And if someone asks you for a hint and you know how to do the problem, give them a good hint. Be a good co-student. Don't just show them your answer and let them copy it down. Ask them, give them a question like, hey, have you thought about trying to get a common denominator? Have you thought about trying to use a Pythagorean identity here? Give them a chance to actually work through these, because like I said, you're not going to learn how to do proofs by just copying down someone else's solutions. All right. I'm going to check some assignments from you guys. What do I need? 5.1 and 5.2, please, if you guys could get those out. I'm going to be around to check those. All right, I'll leave this up on the screen here. I just need to stop.